All right. So for today, I want to review some conversion type problems, and then we'll do the fluid replacement question, and that'll be good practice for today. Next time we get together, we'll go through tablet and capsule and suspension type questions, and that'll pretty much cover the majority of what you'll see on your test. So we'll meet just one time next week, one time the week after that, and then the week before your test we'll meet 2 more times, and then during that time we'll pretty much just be reviewing some of these practice questions. So you need to know what I have highlighted here. These are things you need to know. They're not going to be given to you. You need to know what these conversions are, and you need to be able to apply them when doing the math. So if you are sitting there going, or when we're doing these calculations, so you're going to see me reference these. This is where I'm getting the information from, and now you know. You'll see that for the most part, we try and keep it simple. 1 gram is 1,000 milligrams. 1 milligram is 1,000 micrograms. 1 liter is 1,000 milliliters. So if you remember 1,000, you're probably pretty good. And then there's just a few others that are a little bit different. And then with practice, you'll get used to writing it, and it shouldn't be a problem. All right. So what I'm working off of is, this is the 110 practice set. So the practice set has more questions than does the practice test. The practice test we will go over later on. Right now, I just want to kind of do some repetition on some of these different types of questions, just so you get a little bit of a variety of the types of questions you might see on your test. So I wrote out some variations of these questions. I just changed the numbers a little bit. And so I'm going to work through a couple of these. And this is what we're referencing, is these first few, say the first few 10 questions here is where I'm basically getting the ideas, but I wanted to change the numbers a little bit just to give something a little bit different, and then leave this for you to practice. And then that way you can see, because you have the answer key is also posted. That way you can see, okay, am I getting the right answer, or why am I not getting this? I want you to have that kind of feedback so you can let me know when you ask questions. Again, if you have a question and you can't attend where I would answer that question, email me. That way I know which ones to kind of work through and practice with, or I will just reply via email and let you know what you're doing. And what's helpful sometimes is if you send me an image or a screenshot of what you like, how you set up the problem, I can usually tell you where you're making your mistake and how to correct it. So if you're making a mistake. All right. So you should be able to double click or expand my screen so you can see what I've written out. And what I've done is I wrote out a number of different practice problems here, and we're going to go through each of these. So the first one is, and then I kind of changed the numbers up a little bit because I wanted to also review rounding rules while we do this. As a reminder, when we're doing metric to metric conversions, do not round those numbers, those answers. Okay. You'll hear me repeat that a couple of times. When you're going from house to metric, or you're going from metric to house, then you can round to the nearest tenth if it's applicable. Okay. So there's always a number of ways and a variety of ways to answer your metric questions. One of those is, if you're really good with your base 10 and you know how to move your decimal, and you remember to move it to the left or to the right, depending on what you're doing, then as long as you're good with that, you get it right every single time, then I'm going to encourage you to do that. So if you're asking me to type into the chat the rounding rules, I will not do that. It's posted on the OneDrive folder. So you can just look that, you can pull that sheet and you can look at it for that. And then you'll hear me say the rounding rules, but it is typed out for you. It should also be in your nursing packet that you received at the beginning of the semester. There should be rounding rules listed there as well, but you'll hear me say them as well. And then if you're asking someone else to type it in, then by all means, if you want to type it in, you can go ahead and do so. You just copy and paste if you have open the it's the name of the document is the Dosage Calc Review Intro is how that's labeled. All right. So as I was saying, you can move the decimal over 3 spaces. You just need to know which way to move it. Do you want to make this number bigger or do you want to make this number smaller? And so that's a lot of times where mistakes occur is you don't know which way to move the decimal. Sometimes you don't even know to move it 3 places. And so if you ever get stuck, here's a surefire way to make sure you don't make that mistake. And that is by utilizing, at least for practice purposes, dimensional analysis. I know you may not like dimensional analysis, but it can help you out, especially if you're not sure if you're supposed to move it 3 to the left or 3 to the right. This is just a matter of knowing how to set it up, plug it into your calculator, and then you're usually good. So do we know how to convert milligrams to grams? We do. One gram is 1,000 milligrams. So now I know to divide this number by 1,000. You may not have previously known to divide that number by 1,000, or if you already instinctively knew to move the decimal over 3 to the left, then we're all on the same page. When I do these types of questions, I know I have a decimal point right there, right past the 5, and I know to move it 1, 2, 3 spaces to the left. And so my answer, just like I did right here, would be 1.475 milligrams. That is your answer. Do not round that number to 1.5. That is your answer. When we're doing basic unit conversions, meaning going from milligrams to grams, that is your answer. Don't round that number, okay? Do not round basic unit conversions. I will show you an example where we will round in these practice problems, but for the metric to metric, milligrams to grams, micrograms to milligrams, do not round those numbers. I'm going to do the same thing with this question. I'm going to take my 265 milligrams. I'm going to put it over 1. I'm going to make a conversion factor. Do we know how to go from milligrams to micrograms? Oh, yes, thank you. That is supposed to be grams. That was my fault. Sorry. Oops. I'm writing all the wrong letters here. Okay. So 265 micrograms. And I know that 1 milligram is 1,000 micrograms. So I apologize for the sloppiness. This will get cleaned up here, I promise. My answer is 0.265 milligrams. That's supposed to be milligrams. That is the answer. Do not round that to 0.27, okay? Leave it at 0.265 because you do not round basic unit conversions. Metric to metric, don't round, okay? When you're going metric to metric, most likely if you go household to household, but you're not going to see questions like that. Metric to metric, do not round. Metric to metric, do not round, okay? So this is your answer. This is your answer. Do not round those answers. Where you would round in a on these types of questions are when you're converting pounds to kilograms, because we're going from a household system to a metric system. So when you go from different systems, you might need to round. Not all the time, but sometimes, yes, you will. I have a feeling 182 is not going to work. So I'm going to make this 181 because I want to make sure it doesn't, I want to make sure we get a decimal answer so you can see what that looks like. And also why you would round. It would make sense to round once you look at the calculator. This, you are conditioned to do rounding, but when you're doing the basic unit conversions, again, do not round. Basic unit conversions, metric to metric, do not round. This isn't even going to show up really well, but that's okay. Do not round metric to metric is what that says. So the conversion you need to keep in mind when you go from pounds to kilograms, and this is a common one, you're going to be doing this every semester because you're going to be doing weight-based calculations from here on out. The thing to remember is to divide by 2.2. Okay. And the reason to remember that is because in nursing and in the medical field and the medical sciences, we're always going to go pounds to kilograms. We're really not going to convert kilograms back into pounds. That would just be for math practice. But from practicality purposes, when you're doing weight-based calculations, the medications are available in per kilogram dosages for certain weight-based medications. So if the medication's in kilograms, that's what you're constantly converting things to. We're constantly converting to the metric system is a good rule of thumb to keep in mind. So if you're not comfortable with the metric system, you're going to need to become comfortable with it because that's the system your profession is geared towards, is utilizing the metric units. So adopt it, love it, get used to it because you're going to see lots of it over the next 4 semesters and then into your nursing career. All right. So if I'm going to set this up, I always like to start off by doing this using dimensional analysis just because for consistency purposes. Me personally, I take 181 divided by 2.2, and then that's my answer. But if you ever get stuck, am I supposed to multiply by 2.2? Am I supposed to divide by 2.2? Your conversion for pounds to kilograms is 1 kilogram is equal to 2.2 pounds. So now there's a visual representation of dividing by 2.2. So I'm going to take my calculator, my phone, and I'm going to say 181 divided by 2.2. And I'm going to get 82.27272727 repeating. Okay. 82.272727 repeating. Now, I'm not going to leave that answer and then write out a whole bunch of 27s because it goes on indefinitely. This is where you're going to round. If it's a number greater than 1, round to the nearest 10th. So the answer for this would be 82.3 kilograms. So I gave you some additional practice problems like, let me just go back to the practice set so you can see. You have 165 pounds, 117 pounds, 182 pounds. Some of them end up being even numbers. Like, I mean, there's no decimal. Sometimes it just ends in the 10th place. Just consider that a blessing. But if it's like we just saw previously, the 82.272727 or whatever numbers repeating, just remember to round to the nearest 10th. You would round when you're going from the household units to metric units because you're going into different units. So it's okay to round those. And the other clue is look at your calculator. If it has a long repeating number, that's another good indication to round. Okay. We'll talk more specifically about the rounding rules when we get into the area where that's more applicable, which is when you're administering your dosages. And
I have questions for
Yeah.
number 5. Why don't we just take 182 pounds divided by 2.2, and it's ended up is 82.7 kilogram.
That's fine.
That's why too.
Yeah, that's what when I started off, I said you can just divide by 2.2. Remember, they're going to ask you to show your work. I don't know what that entails necessarily. So just make sure that you are writing something. So if you write 182 divided by 2.2 and you get the 82.727272, then you would just leave it as, you would still round to the nearest tenth. 82.7 would be your answer.
Okay, thanks.
You're welcome. All right. How about milliliters to ounces? So what I'm going to do is I'm going to get another sheet here. So I want to convert 210 milliliters to ounces. So before I do that, I need to remember that 1 ounce is equal to 30 milliliters. So you need to know that. And if you ever need to review that, you can look at a couple of things. You can look at your, measuring cups and things like that you might have at your house. You can obviously look it up, or just, as practice. I'll also tell you, 1 ounce is 30 milliliters. I think a shot is considered 1.5 ounces, which is 45 milliliters. A tablespoon is 15 milliliters. So 2 tablespoons is 1 ounce. And then 8 ounces is a cup. That's 240 milliliters. So if you do 240 divided by 8, you get to 30 milliliters. These are things that sometimes you just pick up, especially if you cook, or if you look at things like everyday things. Like I always like to pull up like my water bottle, and you could see the comparative values. Here's 1,000 milliliters and then 32 ounces, 750 milliliters, 24 ounces. So you can see that they're fairly close. You realize that the milliliter amount is higher than the ounces amount, but they put both those numbers there so you have an idea. So if I were to fill up my water bottle to here, I'd be getting 32 ounces. I usually fill it up to above the 1,000 milliliter mark. I don't know why you need to know that, but I'm just letting you know. I spilled water. Oh, well. All right. So using dimensional analysis, I'm going to take my 210 milliliters. And I'm going to convert milliliters to ounces. So I know that 1 ounce is 30 milliliters. So this is where it's helpful, because sometimes you might not remember, do I multiply? Do I divide? So 210 divided by 30 will give you 7 ounces. If you got an answer, so let me see if I had 215 milliliters. So I'm just going to say, if it were 215 milliliters, that would equal 7.16666. It just keeps going. It's a repeating number. You would round to the nearest tenth, 7.2 ounces. Okay. So I'm trying to give you different scenarios. So if it looks like it should be rounded because it just keeps repeating, that's your tell that it should be rounded when you're doing your basic unit conversions. When you're going metric to metric, though, do not round metric to metric, but you could round when you go metric to household or household to metric. All right. What was the next one I did? 25 milliliters to teaspoons. So something to keep in mind. I'm going from the metric system to a household unit. I might need to round to the nearest tenth. I don't know that yet, but I might need to. What is my conversion? Well, 1 teaspoon is 5 milliliters. $25 milliliters times my conversion factor. 1 teaspoon is equal to 5 milliliters. So I'm doing 25 divided by 5. And I'm going to get 5 teaspoons. If that were something like 27 milliliters, I would then get 5.4 teaspoons. All right, so I just saw someone ask a question. The rules for rounding to the 10th are based on number. If the number is greater than 1, round to the nearest 10th. If the number is less than 1, round to the nearest 100th. So that's the short answer. All right. Tablespoons. 2 milliliters. What's my conversion of tablespoons to milliliter? Well, 1 tablespoon is 15 milliliters. So before you even do any kind of math, you should be able to look at this and say, okay, I have at least 2 tablespoons, so I know my number is going to be bigger than 2 times 15 milliliters or 30 milliliters. And if you know that, that will help you out just in case you make an oopsie when you're plugging this into your calculator, which happens more often than you think. So I'm going to take the 2.75 tablespoons. I don't want tablespoons. I do want milliliters. So 15 milliliters per tablespoon. So I'm going to take that 2.75 times 15. And I'm going to get 41.25 milliliters. Now you might want to leave that alone because you're thinking, well, you know, that looks like a good number. It stops, but we're actually going to round that number to 41.3. Why? Because we're going from the household units or the imperial units to the metric system. When we switch systems, if it's a number greater than 1, round to the nearest 10th. If it's a number less than 1, round to the nearest 100th. And then finally, 1.375 ounces to milliliters. We already wrote the conversion of ounces to milliliters up here. 1 ounce is equal to 30 milliliters. So I'm going to take my 1.375 ounces. I'm going to set up my conversion. I do not want ounces. I do want milliliters. 1 ounce is 30 milliliters. So we know we're going to multiply that number. So 1.375 times 30 . I guess that is right. 1.375 times 30 is actually the same number that we got up here. 41.25 milliliters. So you're also going to round that to 4.3 milliliters. So again, practice these. You can check the key, and then you can see that, and that'll help to check that you are rounding appropriately when you're supposed to be rounding, and not rounding when you are not supposed to be rounding. And so far, the only time I've told you not to round is when you're going metric to metric for your basic unit conversions. When you go household to metric or metric to household, expect that you're going to need to round to the nearest tenth. You may not need to all the time, but sometimes you might. So I just want to double check, make sure I didn't miss any chats. Okay, good. All right. So, like I said, I gave you a bunch of, oh, go ahead with your question.
Okay, so for the problem that you just did, the 30 milliliters, well, 1 ounce equals 30 milliliters. What if you would have set the problem up differently? I know it wouldn't have canceled out, but I noticed in the one problem that was 210 milliliters to ounces, we put the 1 ounce on the top and the 30 milliliters on the bottom. Now, do we have to switch it up depending on what the main number is, such as in this situation, the 1.375 is in ounces. So would that be a flag for us to switch the milliliter and ounce around so that cancel out? Or if you kept it as it is, the 1 ounce equals 30 milliliters, would you have to like break the problem down further to eliminate the ounces to get milliliters by itself?
So you're asking a really good question. And this is where I think, this is where I think, at least understanding or at least seeing some of this dimensional analysis stuff helps out. So when we know the conversion for ounces to milliliters is this, so I can do 1 ounce over 30 milliliters like I did here, or I can do 30 milliliters over 1 ounce over here. So I can manipulate that however I need to based off of what I'm converting from and what I'm converting to. So
Okay.
in this question, I'm going from milliliters to ounces. So since I start with milliliters, I know I want to get rid of milliliters, which is why I know to divide by 30. And then I multiply by the ounce. Down here, I'm going in the opposite direction. I'm going from ounces now to milliliters. So since I start with ounces, I want to divide by the ounce and multiply by the milliliters. So a lot of this is practice. Like, so when you practice this, and the reason I show this to you this way is because, and maybe you've done this yourself, is that and I know I did this a lot when I was learning this, is I would take 210 times 30 and then I'd get some ridiculous number and be like, that doesn't make sense. Or I would take this number and divide by 30. And then again, I'd be like, that doesn't make sense. And I felt like I was guessing. When I put it and I write it out, and you might notice that I write the units before I write the numbers. And the reason I do that is because then that helps me to make sure I'm setting it up properly, where I cancel out the units. And then I just use my conversion factor that I've memorized. And I know to put this number with the milliliters, the 30, and then that number 1 with the ounces. And it gives me a strategy to make sure I don't goof up and put the numbers in the wrong places. Same thing here. I wanted to get rid of ounces, which is why I knew to put ounces down in the denominator and then keep milliliters in the numerator. So it's a good way to kind of, or I would say, in my opinion, it's a good strategy until you become comfortable doing these conversions. If I told you that I just do this in my head, I mean, I plug it in a calculator, but I know I'm going to multiply by 30. I know I'm going to multiply by 15. I know I'm going to divide by 5. I know I'm going to multiply or divide by 30. But me telling you that doesn't help you figure out if you're getting stuck. If you know that and you're doing that instinctively, then keep doing that. You're doing it right. And I hope I answered your question.
Yeah, thank you.
You're welcome. And you'll see, every time I do these, even if you can't be here, I'm always on the replays. I'm always going to work out and show you how I'm kind of coming up with this. Even if you hate the dimensional analysis, at some point via osmosis, you're going to see me do it and set it up enough times that, and if you practice and write what I'm writing, you will do it as well. And you should be fine. So.
Now, do we have to remember, this is my first session with you, so excuse me. Do we have to remember the formulas?
Yes, you have to know, so on the OneDrive folder, and I'll pull this up here so you can see. On the OneDrive folder in the Dosage Calc Review intro, you need to know these conversions. You have to memorize these.
Now,
and
what about cups and quarts and all that? I don't see that on there.
Nope, not at Allegheny campus. At Boyce, yes.
Okay. So
But not at Allegheny campus. There's no questions about cups, pints, quarts.
Now, is that just for this class, or in the future will that be added on to it at this campus?
It will not be added on.
Now, last question about this are these calculations on the NCLEX?
So there are different type. Yes, you will have dosage calc on the NCLEX. Yes.
Okay.
Yeah. So this is all to prepare you for the NCLEX, and you're going to have one of these tests every semester.
Okay.
All right. So the last thing I wanted to cover today is just how to do these fluid intake questions. Let me just expand my thing here. And so there's 2 questions on fluid for fluid replacement. And they're both, you can see they're both worded exactly the same. And what we're going to do is we're going to calculate how much fluid to give back to the patient once they've voided out a certain amount of fluid. And I'm going to show you how I interpret it. And then I'll also talk about variations that you might see. So one of the things when we look at this, so it says for every 125 milliliters of urine output. So I consider that like your theoretical or your potential output. So for every 125 milliliters of urine output, you're going to replace with 40 milliliters. Okay. So when you lose 125, you're going to replace with 40. That's those for this situation. That's kind of like your order, what you're being told to do for this patient. Does this make any kind of sense? I don't know. I don't know if this makes sense. Like, it seems to me that you would want to replace maybe more of an equivalent amount for the amount lost. But anyways, that's just what it is. And then it says, if the output was 500 milliliters, what would be the new replacement volume? So I'm going to show you a couple of ways that you can kind of set this up to figure this out. But before I do that, you might see this question written a couple of different ways. You might see this question written as, in the last 4 hours, your patient has voided 500 milliliters. If you are to replace with 40 milliliters for every 125 milliliters of urine output, what would the fluid replacement volume be? So you might see it reorganized. So it's important to know, what did the patient actually void, 500 milliliters, and then knowing the replacement numbers. So 40 is the replacement volume, and the potential or theoretical output is usually connected with the replacement volume. So sometimes it might be written out of order of what is written here. Just make sure you can see that, and then I'll try and look for other examples. That way it doesn't trip you up, and so you've at least seen it, because a lot of times the only time you're ever going to see it is on your test.
Is there any way for you to share the different examples in the folder, or can you email us so that we can,
it's already posted for you in the OneDrive folder.
Okay. So
And
the question
link,
written a different way, is that what you're saying?
I'm going to, yeah, I will share it written in a
Okay.
different way. So
Thank
you're welcome. And then everything here is on Blackboard. So or on Blackboard, there's a link to the OneDrive folder so you can see all the things that I've created for you. All right. So we have a couple things. We have let's just say urine out, replacement volume. So that'd be your fluid in. And then so you basically have two numbers. Okay. There's two types of urine out. There is what actually came out, what was actually collected. And then you have what I like to call the potential or the theoretical. This will all make sense in a little bit, and I apologize that that I'm kind of talking like almost seems like semantics here, but then your replacement volume, you have an actual replacement volume. Oops, can't spell actual apparently. And then you have what your potential is. So I classify these just so you don't get hung up on it. I haven't had this isn't usually a question that there's problems with, but I just like to make sure you don't get hung up on some of the details when we do that. So as far as potential, usually the potential volumes are given to you. So your potential out for the first problem is 125 milliliters. And then your replacement volume or your potential in is 40 milliliters. And then your actual output is 500 milliliters. And we want to know what is the actual replacement volume or the actual in. So this is the important numbers. So going back to the shared screen. So for every 125 milliliters of urine output, so that's my potential output, I'm going to replace with 40 milliliters. And then my actual output was 500 milliliters. And then I want to know what I'm actually going to replace. So how much? So you can look at this and you can just rationalize. If you know that for every 125 milliliters lost, you're going to replace with 40, you can then sit there and say, okay, well, if I take 500 divided by 125 and then multiply by 40, that'll give me my replacement volume. Or, and this is probably more so what I think most nursing students do, or most students do, is they'll say, okay, 40 milliliters for 125 milliliters. So it would be 80 milliliters for 250 milliliters. Then 375 would be 120 milliliters. 500 milliliters would be 160 milliliters. If you're doing it that way, you're doing it right. Okay. If you're not, then I'll give you this strategy, and I'll also show you. There's a equation for this. So I called it actual, original. You could say potential, theoretical. So your actual fluid out divided by your original fluid out times the replacement volume will give you the new replacement volume. Or you can do a ratio proportion, and I'll show you that way as well. But if you do the formula that I wrote out for you, if you do that every time, you'll get the answer right. So if I'm doing the formula, I'm going to take my actual output, which was the 500 milliliters, and I'm going to divide by my potential, my theoretical, my original stated output of 125 milliliters. And then I'm going to multiply by the replacement volume. If you can do that, then you're good to go. The trick is don't mix up these two numbers. And then you'll get an answer of 160 milliliters. And that would be your replacement volume for this question. if you're someone who likes to get fancy with their math, and I know none of you are there, but if you do, you can kind of put your actual and potential on opposite sides of an equal sign and make a ratio question. Meaning, if I know that if I put my outputs on one side, so 500 milliliters, 125 milliliters, and then I put my inputs on the other side, I just need to match them up. So 40 milliliters would go down here, and then this is what I'm looking for. How many milliliters is the replacement volume? Now, if you're looking at this and getting flashbacks of algebra, and you don't want to do this because there's cross multiplication, or you can even call this number X. And if you don't like that, that's fine. That's why I wrote it out like this, because as long as you know to keep the actual output over the original output times the replacement volume, you should be good to go. The trick comes in sometimes your actual output is less than a replacement volume. So let's say in this particular question, my actual output was 100 milliliters. Would I still give them a replacement volume, even though they didn't void out 125 milliliters? Maybe, maybe not, but we can still calculate a volume. And so if my actual output was only 100 milliliters, my original it's still over the original, but notice that now that number is bigger on the bottom, where it was smaller on the bottom in this example. This is a smaller actual output, but I'm still going to set it up exactly the same way. I'm going to put my actual output over my original output times the replacement volume, and I'm still going to calculate it the same way. You can do 100 divided by 125. Times 40, and then you'll get a replacement volume of 32 milliliters. And it's okay. And that should make sense, right? Because if I would give them 40 milliliters for 125 loss, it should be less, your answer should be less than 40 milliliters. And that's another way to make sure you're not setting the problem up right, is think about it, think through it. Should this number be bigger or smaller? And if it's supposed to be bigger, how much bigger? If it's supposed to be smaller, how much smaller? And at least gives you an idea to make sure you're on the right track when you're answering these questions.
I have a question whenever you're
Yes.
done. So I know before you got into, when you did it the first way, you know, the 500 over the 125 times 40, you had did it like a quick way. You said, like you just looked at the problem before setting up the equation to solve for it. Could you show how to do that way again?
So all I did was I just rationalized through it. So actually I can write that out. So okay. No, okay. So this is basically what I said. If I know that I have my original output is 125 milliliters, and then I'm comparing that to my actual output of 500 milliliters, and then my original replacement volume is 40 milliliters, and then I'm going to compare that to the same difference. And so what I'm looking for is how many times, or what happens as I go up to 500 milliliters. And so all I said was, if I go from 125 to, and I double that, it'll be 250. If I triple that, it's 375. And if I quadruple that, that's 500. So I can do that one of two ways. I can take the 500 milliliters divided by 125, which is what we're doing here. And that gives me a multiple of 4. So 125 times 4 gives me 500 milliliters. And then I can do the same thing here. 40 times 4 and I get the same answer, 160 milliliters. So basically, this is just one way to represent it. It's a little bit more consistent. This way is just another way if you're trying to rationalize through, like, okay, if I give this much, and then if I double it, and if I give another 125, and if I give another 125, oh, look at that, it brought me up to 500. It might be a way to help you estimate what your actual replacement volume is. But I would say if you can do this, I wouldn't say this is any quicker. This is only quick because I make it seem quick. This is probably this is actually probably the quicker way of doing it. It's just, you just need to know how to set it up.
Can we do another problem like that?
So what I'm going to say is I'm going to, because you have the key, go ahead and do number 12 on your own. And then that way you can practice it.
Okay, I didn't fully understand like the way you set it up. Cause I mean, I wrote down what you said and you said, hold a second. And you said the actual output and the actual in and the actual and potential. Like, could you like explain that process again, but like on another question, either another problem, or
Sure.
I don't know if you want to go over this question again per se.
So again, where I'm getting the numbers from are, so we're looking at the question here, question 11, and question 12 is written the same way. It's just using different numbers. So that's why I'm saying practice it. So the 125 milliliters. So it says for every 125 milliliters. So that's my potential or my starting or my original urine output. This where I was getting that number from. So for every 125 milliliters of urine output, I'm going to replace with 40 milliliters. Okay. Then it tells me my actual output. So it says if the urine output for the last 4 hours is 500 milliliters, so that's my actual output. I want to know what the replacement is, the actual replacement volume. So this is kind of like your conversions. This is like, instead of saying 1 gram is 1,000 milligrams, this is saying 125 milliliters equals 40 milliliters. But when I say that, it doesn't make sense, right? Because you're thinking like that they don't equal the same thing. And it's because, and you're right, but we're talking about urine volume and water volume. Those are two different things. So we're equating what we're replacing with what is lost using that. And I know that I'm not doing a great job explaining it, which is why I will call you back to just, if you understand what I mean by actual output, so what was actually voided by the patient, and then what they told you is connected to the replacement volume. So for every blah milliliters lost, replace with blah milliliters. That's how you would organize these types of questions. So for number 12, for practice, let's just go through this conceptually before you do anything. If you haven't written anything, what number would I put on top in that equation of actual output? Which number would I put on top? The 100, the 30, or the 400?
400.
Good. Okay. So you're going to put the 400 milliliters on top. What number are you going to put on the bottom? 100 or 30?
100.
100.
You got it. You're going to put the 100 under the 400 because the 400 was the actual output. The 100 is the original output. Like for every 100 milliliters lost, and then you're just going to multiply by the replacement volume.
30.
So go ahead and then tell me what you get.
120.
Did you get an answer? I did see one answer in the chat. It's the same one. Yep. So you should get 120 milliliters. So the takeaway here, guys, is just you got to practice. And I know like some of these things, the way that they're worded can be confusing, and it's going to take some time to wrap your head around it. You're not alone in that. And so we will go over this again and again and again before you have to take your test. So there will be plenty of practice. So if you're sitting there going like, oh, I'm never going to get this, trust me, you're going to get this. My plan for next time that we get together is to do the fluid replacement, some practice. I'll come up with some new ones, and then we'll practice that some more, and then we will get into reading labels, reading orders, and practicing doing those things. And then I do also do a review session for Boyce students before this, and it's every Tuesday and Thursday at 2:30. It's the same link. So if you want some additional practice and you want to see some additional things, you can always jump on to those review sessions. Also, if you want to get ahead and jump ahead, every review session I've ever done for 110, or not every, but for the last couple years, I've posted on my YouTube channel. And so you can go through and you can listen to what other people have asked. You can see how I've explained things in the past, because sometimes maybe I explained it a little bit better or differently then than I'm doing now, or hopefully I'm explaining it better now than I did then. And then, like I said, a lot of this just comes down to just practicing these problems. I know it can be frustrating at first, but you have plenty of time to practice and review. And I'm here to help you out. But I'm also gonna, try and get you to practice and try it out on your own, because I can do these and work these questions out all day and all night, but it doesn't help you unless you're also practicing them fresh, like you don't know what to do. And then what do you figure out? What do you make a mistake on? If you can't be on the review next week, and I apologize, I don't know when the review, I can't remember which day. It's either Tuesday or Thursday next week. But we'll get together. If you have a question and for whatever reason you can't be on, just email me your question, or you can email me a screenshot of how you tried to work through a question, and I can give you some feedback on that. But I will address your question via email, and then most likely I'll also do it here on the video. Thank you. So Tuesday is when we'll get together again for at 3:30 again. I did have a request for like a Friday class, but I only had one student ask for that. So I don't know if I'm going to do a Friday or not. But if there's other students,
I'm available Friday if you're able to do Friday.
And what I would do is I would move one of the Tuesday or Thursday review sessions to Friday. So that's how that would work out. So if you know, if you want to let me know if Friday is better for you, just you can message me, send me an email, and then if I get enough people that Friday would work better for, then we can always move maybe the next Thursday session to a Friday session if that's better for everybody.
Well, Thursday works better for me. I'm not sure about for everyone else, but I thought you would have been able to do like an additional day.
You would need to request that from your instructor. I'm limited to what they tell me I can do, so I don't know that I can do an additional day. So as far as I know, I can only do the days that I've outlined, or at least the number of days. So I don't know. I don't think I can do any extra days, but I I can do what I have posted that number of days. So if need be, I will I'll see if I can add another one, but I don't know that they want me to add another one. So, and it might not be necessary. Once we practice these a few times, and like you said, this was your first time being in here, it's gonna feel intimidating because I'm just continuing off where I started talking on Tuesday. And now you know, okay, the one that was on Tuesday is it. I only just posted it up on YouTube today. I only just posted the Zoom link on Blackboard for you guys today. But now you'll have that and this to kind of work off of.
Sorry. So are we meeting next week on Tuesday?
Yes, yeah. So someone wrote it in the comments there that on Tuesday we're meeting.
Thank you.
You're welcome. Yeah, so double check Blackboard. I'm following the schedule that I posted on Blackboard. I just can't remember it off the top of my head. And then as a reminder, if you heard me say this before, I'm also on here every Tuesday and Thursday for the Boyce 110 students. Their math is, there's a couple things that are different about their tests than your tests, but you could benefit from being on that. You're welcome to join. It's the same Zoom link. So all right, so that'd be a good place to stop for today. Again, if you have any questions, just email me, and I will talk with you next week.
Now, quick question before you go.
Mhm.